Welcome to yet another episode of Programming Problems, where today we will be managing our lens library as we tackle Day 15 of Advent of Code 2023. The reflector dish from Day 14 is now sending a focused light beam into the lava production facility. To get the facility up and running, we first need to become familiar with the instruction manual. Step 1 in this process is to learn how to apply the hash algorithm, which turns any string into a single number in the range of 0 up to and including 255. To apply this algorithm, start with a value of 0. Then, given a string, we can determine the decimal code of the character and add it to the value. Then we multiply the value by 17, and finally, we set the value to the remainder of dividing itself by 256. Given a comma-separated list of steps as you see here, what is the sum of the hash values of every step string? Here's a quick example to make the algorithm more explicit. We of course start with a value of 0, and then we add the letter h as a decimal. Then we multiply by 17 and we apply a modulo operation. At the end of the string, we arrive at the value 52. If you want to get your own input for today's problem, be sure to check out adventofcode.com and sign up. For now, let's go on with the solution. The solution outline is to simply take in the input, and for every step we compute the hash value. The hash function itself looks as follows. It takes in a string and loops over every character to modify the value. Converting the character to a decimal is trivial using the table on the right. You can auto-magically get the decimal value via the ORD function. And that's it already for part 1. Let's see what we're up to next. We've confirmed that our algorithm works and we have our next task. There are 256 boxes arranged in a line. Inside each box, there are several slots for lens elements. We are asked to sort the lenses into the boxes based on the steps provided as input. Every step is formatted as either of the following. We either get a label which has an associated focal length, or we get a label and a minus sign. If the operation is the equal sign, then we go to the relevant box and we put a lens with the provided focal length into the box. If there already was a lens with the same label, we simply replace the lens. If the operation is the minus sign, then we go to the relevant box and we remove the lens. Given all boxes and lenses, what is the total focusing power of the entire lens configuration? Let's see the examples to learn how to compute this. First up is the assignment operation. Here the label hashes to 0, so we insert the label with focal length 1 into box 0. If there already was a lens with this label, then we simply update the focal length. The removal operation is more simple. Given a label, we determine the box via the hash function, and then we remove the lens label from the box. If there is no such label in the box to begin with, then we simply do nothing. Computing the focusing power of a single box works as follows. Suppose we have box 3 with 3 lenses in it. Their focal lengths are 7, 5, and 6. Then the formula for the focus power of any box n is n plus 1, times the sum of the focus power of the individual lenses. The focus power of a lens is its relative position in the box times its focal length. So for the example, we have focus powers 7, 10, and 18. Because this is box 3, the total focusing power of the box then is 4 times the sum of the lenses, totaling 140. Now let's see how to solve part 2. As part of our solution outline, we can make box entities to encapsulate the lens sorting logic. First, we take in the steps, and we then places all lenses into boxes. The place lenses function shall give us back the boxes which will hold the sorted lenses. Then at the end, all we have to do is enumerate over the boxes and compute the total focusing power. Let's make use of a box class. The key behavior that it should support is to store the lenses, which we will do in a hash map or a dictionary in Python. Then it must be able to add a lens and remove a lens from the box, all while maintaining the relative order. For this, the count variable is going to be used. Let's first look more closely at why I suggest to use the count variable. What matters for our box is that we track the insertion order, or insertion time for every lens. We don't particularly care for the absolute order until the end of the problem, so we don't need to actually hold the lenses in a list and then shift lenses every time that we remove one or more. The list can be inferred at the end. So consider having 4 lenses in a box with focal lengths 3, 11, 4, and 2. If I then remove the lens with focal length 4 and I add one with a focal length of 18, then it is perfectly fine to leave the empty spot empty. Taking this one step further, we might end up with the list at the bottom. Now, all we really care about is to know that the lens with focal length 11 was inserted before the lens with focal length 2. Achieving this can be done using the count variable. The add function then looks as follows. Given a label and a focal length, we check. If the label is already in the dictionary, then we get the index, which represents the insertion time, and we update the lens with the new focal length. If it is not already in there, then this is a new lens. So we add it to the box under the label, with the count as its insertion time. Then we increment the insertion time so that any newly added lens, which will be inserted later than the current lens, will have a larger number assigned to it. Since we're using a hash map, removing a lens becomes trivial. We check if the label is in the dictionary, and if it is, we delete it. Then finally, the critical part, computing the focusing power of a box. We achieve this by getting the sorted focal lengths. The getFocalLengths function gets all tuples from the dictionary, which represents the lenses, and then we sort them based on the insertion time. At the end, we of course don't care about the insertion times themselves, so we extract the focal lengths from the data and return those instead. The getFocusPower function then only needs to iterate over the focal lengths and multiply them out with the indices at which they are in the box. Finally, we of course need to multiply the focus power of the lenses with the index of the box in order to compute the total answer that we need for today's part 2. And that was it. We're making very good progress in this year's advent of code. Thank you for all the likes and subscriptions, and I hope you look forward to the next solution video.